Hello, my lovely students. So 3.2, we're going to look at the graphs of the other guys. So this is going to be tangent, secant, cosecant, and cotangent. Now, your homework on this is not as involved as it is with the sine and the cosine. We actually get a lot more use out of sine and cosine graphs than we do out of these. So a lot of this is just exposure, but the thing you really want to focus on that we will use is where these asymptotes fall. Because when we solve trig equations later, we're going to have to pay attention for these asymptotes and this idea of being able to add k of something. So just bear that in mind. But as far as the homework goes, it's mostly about, here's the graph, what's the equation for the asymptotes? Or what's the phase shift? What's the stretch or the period? Yeah, they don't ask much. All right, so our first graph here is tangent of x. So we can see tangent of x has a point at 0, 0. And then the other key point that they like to use is here. It's about halfway between 0 and the asymptote, so that is pi over 4. Pi over 4 goes up to 1. The reason they like that point is because if we have a vertical stretch, which is our amplitude number on sine and cosine, then that point is going to move, but the asymptotes won't. Like you stretch a vertical line, it's just more vertical. And 0 doesn't move with the stretch. So that's like 0, 0 is our primary point, but then that pi over 4, 1, and then because tangent is odd, there's a negative pi over 4, negative 1 point. So those are the points we're going to focus on when we move this stuff around. But that pi over 4, if I change the width of the period, right now you can see the period goes from negative pi over 2 to pi over 2. So if I make that wider, my 0 point is still in the middle, but my new pi over 4 is halfway between the 0 and the asymptote. So we might have to do a little math to figure that out. All right, so here we have sketch a graph of blah. Yay. So we have 3 tangent of pi over 6x. So the same way we worked with sine and cosine, except the period of tangent, if you look up here, is only pi. So our period is pi over b instead of 2 pi over b. But still the over b part. You just got to remember that tangent and thus cotangent have shortened half the period of the other guys. And that's just because of the way they repeat. So period is pi divided by pi over 6, because that's our b. And then our a is 3. So this is going to be pi times 6 over pi. So our period is 6. So that is the width of the period, not where the period ends like it is with sine and cosine. So our period's going to go from -3 to 3. And then our halfway point, so in between those is 0. So let me just number line this real quick. So there's our 0, there's our 3, there's our -3. 3 and -3 are going to be asymptotes. So the halfway marks, which is 1.5 and -1.5, those are going to be our how many away from 0 from the center do we go? All right. So that's just like looking at our numbers and just getting where our division marks are. Now we're going to take that set of numbers and we're going to translate this into graphing a whole graph. which really I could just make the zero line bigger, but we'll make it look a little nicer. So a little being a relative term since my handwriting is so bad. Also, negatives are still on the left. Okay, so sketch, 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 sketch. All right, we don't have any shifting here, so our 0, 0 point remains 0, 0. Now, when I go over that 1.5, normally I would go up 1, but this has an A number, so I'm going to go over to that tick mark and then up 3. Then my reverse point, negative 1.5, and then it will be down 3. All right, now tangent, it's not just a straight line between the two. You got to put a little bit of a curve to it. So this side, it basically, like, as we get closer and closer to the 0 point, the graph is actually flattening out there. So when we come off of the flatten out, we're going to have a, well, I guess for the camera, it'd be like a curve down this way and a curve up this way. So and then eventually it'll get closer and closer to the asymptote, but never actually touch it or cross it. And then the same on the bottom. So if the graph itself doesn't actually get close to the asymptote, like just visually, that's okay. Not that you guys have to graph these, but it's more about, can I see the labels? And here, we probably should put in, again, positive. And the 3 and negative 3. All right, so pure fluke that the bounds of the period ended up being those extra point numbers. All right, now let's take a look when we have a crazy function with all the shifting. All right, so I have in here, I copied the book's explanation just so we can kind of compare and contrast. So what I'm going to do right now is just yoink a picture of this. I'm going to move it over here. We're going to work through it, and then we'll go back and look at what the book did. Okay, so graphing one period of the function. So I see my first thing is my A number is -2. So the negative here is going to be responsible for a flip top down. So I'll just put a little up and down arrow there. All right. And then this 2 is going to be a stretch on secondary points. Now, the book leaves the function like this. And if you're going to graph it, the first thing you should do is factor it, because looking at it this way just confused me. If you're comfortable looking at that and going, the phase shift is going to be C divided by B, that's fine. It works. I just prefer this way. So it'll still be a -2 tangent, but number in front of x is a pi. So I will factor that out. That's still our b, but then this will be x plus 1. All right, so this is our b. So our period is pi divided by pi, which is 1. All right, then this is our h. So x plus 1 means it looks like positive. We'd think that'd be right, so it's really going to go left because the inside stuff lies. left 1 unit. And then our -1 here, the K. This is going to shift the whole graph down 1 unit. Okay, so just like with our sine and cosine, like we identified all the things, those shifts are going to happen first. That's going to put our new center point, or the starting point for sine and cosine. And then from there, we're going to mark our period around it, and then we're going to mark our stretch points. So let's go ahead with here, here. I'm going to make it a little bit bigger. Okay. So we have 1, -1, -2, +1, +2. Let's see. So I'm putting extra just because I know it's going to go down 1. And then here I have a left 1. So our 0, 0 point is going to go left 1 and down 1. So this is our new center of the graph. Our period is 1 unit wide. So does that mean it goes from -2 to 0? We have to be 1 unit in total width. So we're going to do half of that for our movement. So that means our asymptotes here are going to go through these. So this is -0.5, and this is -1.5 or -3/2. So if we wanted a formula for the asymptotes, it would be x equals, and the starting point doesn't matter. You can shift it around. So here, -1/2, but you could also write it starting at -3/2. That part doesn't matter. Plus, now I have to figure out how far apart those are. They are apart the length of the period. So -1/2 plus 1 would bring us to +1/2, or -1 would bring us to the -3/2. So this is our asymptotes. Now, these are vertical asymptotes, so they are x-equal lines. I am pointing that out because on the web work, 2 of the 5 options will be y-equal lines. So pay attention, it's really easy to click the wrong one. All right, so we got our asymptote formula, nice. And we took care of the downward shift, we got our period. All right, we moved to the left one. Now we just have to account for the stretch and flip. So normally my move would be halfway between my 0 point and my asymptote, and that is where it is. So that would be here, this will be -3/4. And then halfway between these two guys will be -5/4. And then our -2. So from our lower number here, normally I would go right to that tick mark, and then up 1. Instead, I'm going to go right and go down 2. So halfway in between and down, way down here. And then up here, we'll end up with a point way up here. And the graph goes through like that. So I could repeat this. So that means I would have another period from -1/2 to +1/2. My 0 point would be here, and then it would do the same shape. So we end up with decreasing wiggly lines instead of increasing wiggly lines because that minus Now, what we're actually going to see later is the cotangent graph actually looks like this. But just like we saw with sine and cosines, you can pick up a cosine graph, yoink it a little to one side, and it's a sine graph. Just the way it works. All right, now let's kind of compare what we did versus what they did. So they said a equals -2, so the stretching factor is +2. I point this out because in your homework, when it asks for the stretching factor, it doesn't care about if there's a negative to flip it. It just wants the absolute value of the number. Step 3, our period is pi over b, so is 1. So they got the same period. Phase shift, the c over b, -pi over pi, which we got by factoring. There's our 1. And then the negative is up here where we said left. So if they asked for like, what is the value? The value would be a little more annoying. But the shift amount is 1. The -1 here means left. But again, looking at our thing, we see a plus there. The normal formula has a minus. So you just want to remember, like, when I see a plus in there, it looks like it should go right, so it goes left. And then asymptotes, they got the -3/2 and -1/2. And then there's our shifted over 0, 0 point, the -3/4, and then down 2 more to -3, the back to -5/4, and the up 2 put it at 1. So you shouldn't have to write the ordered pairs for this one, but they're there, so not horrible. And then this one. Now again, you're not going to have to fully do this, but it doesn't hurt to think through it. All right, so our graph is still starting at 0, 0, so there's no shifting. So h and k are 0. Now we need to know our period. And it appears the period is going, like I see from the 0, 0 point to the next place where it crosses is pi over 2. So the period width is pi over 2. All right, so with our formula, P equals pi over B, this also produces the formula B equals pi over P. So my B value is the normal period of tangent divided by the period we just got, which is 2. So our period width is pi over 2, but our B value in the function will be 2. And now we just have to figure out the A value. So this is harder to read. But what you want to do is we're looking for that halfway between the half mark. So halfway between the half mark on this graph gets pretty high up there. And I look, I did not want to draw hard. The y value labeled next to that is a 5. So we're going to assume that's hitting a 5 because they're not going to ask you to choose between 4.9 and 5. And that is up and right. So this isn't a flipped graph. So our A is +5. So we're going to write our function formula. Y equals 5. This is a tangent graph. The B value is 2. Our x, h, and k are both 0. So this is the graph of y equals 5 times the tangent of 2x. So it's twice as fast, meaning our periods are more frequent, so they are smaller. 5 times as tall for our vertical stretch. So we don't usually call it the amplitude here, but you know, if you accidentally said that, it'd be okay. I'd know you meant the vertical stretch factor. But you'll see the verbiage shift here. Instead of saying amplitude now, they're going to go back to saying vertical stretch when they probably should just call it vertical stretch all the time. All right, and that's a new graph, so I'm going to cut it here and then record the next one.